What is vector database and how does it actually work? And why do I even need vector databases? In case you don't have answer to these questions, this video is for you. With the rise of Agentic, everybody is talking about vector database. But what exactly it is? If you don't have the answer, at the end of this video, you would have that answer. This video is not going to cover any technical setting up the database and none of that. It is just understanding the core concept of vector database. Hi everyone, welcome back to the next video into the core concept of agentic automation. In the previous video, we have already covered all of these videos. In case if you are new, feel free to refer to this. I have put the playlist link in the description. The topic for today is vector databases. My name is Mukesh Kala. I am a 5-time Path MVP, a certified solution architect and a LinkedIn top voice. Have shared my LinkedIn details on the page. Happy to be part of your network. Okay. With that, let's try to understand what exactly is the vector database. Okay, let's try to set up a company, right? I want you to focus on the screen because there is nothing technical, so you can just focus on the screen as well. Okay, today I plan to operate a company. My company is called Tutorials by Mukesh Kala. In short, let's call it TBMK. Okay, now I have a business which is operating in airlines, ships, submarines, buses, car, hoverboard, boats, right? So basically TBMK is a company which is a transportation related company. Now, whenever I set up a company, in the back end, there would be a developer, or in the back end, I would need to store all of this information into table, right? Because I need a database. And this is how the database will look like, right? We would have all the category like plane, boat, submarine, car, buses. The boat would be a duplicate entry and so on and so forth, right? Now the question arises is, how would a developer do that? I believe most of you understand what is a database, so I'm not going towards the basic of database. Let's try to understand that if I go by the traditional concept of databases, how would I actually plot this company information into my database? Okay, so introducing you to the developer. So this is the developer which you are going to see throughout the video. This would be the developer. Let's call him anything. You just name the developer and you can put the name in the comment, right? That what do you call your developer? Okay. So now the developer is this guy who is going to code all of that. Okay, let's see what does the developer do. So in the database, the table will look like this, right? The developer will say that, okay, create table vehicles, put all of this where the vehicle ID is the primary key, and put all of these details. And boom, it has created a database. Vehicles, it has tires, it can float, it has wings, what is the vehicle types, and run on, right? Because depending on the different factor. And this is just pure example of SQL, right? By the way, in case if your guys are beginner to SQL as well, you can find this complete playlist on SQL on the channel where I have explained you all of this, right? But for the people who are already understanding, you would relate to what actually I mean, right? So basically the database developer created a simple table, and based on the different things we have, boats, submarine, aeroplanes, he created this structure. Okay, everything is going well as expected, right? Now what happened? The company started sending the data. What the developer will do, insert into the table, and he would populate all the table like this, right? So the vehicle is the plane, boat, submarine, car. It has tires. Yes, plane has tires. The boat has no tires. The submarine don't have tires. The car has tires. Bus has tires, and boat is a duplicate entry. Can it float? The plane cannot float. The boat, yes, it can float. The car cannot float. The bus cannot float. It has wings. Yes, it has wings, and others don't have wings. The vehicle transport, this is a air, this is a water, this is a land transport, and it runs on skies, runway as well as water, right? And this is the basic details, right? All of us are able to relate to it. Now, I would like you to guys to take a moment and connect it to any of the enterprise use case. Hospital data, insurance data, financial data, right? This is something which all of us can relate to. That's why I'm showing this example, but you can relate to any of the database structure which you belong to the industry, right? Now we have this database. The data is available into the table. Everyone is so happy, including our developer, which you have already named. Now there come the user. Okay, now you have built an application on top of it, and now there are user queries which are coming up. Okay, and at the bottom for the reference I have put this table. Okay, there is a user who asks that, okay, Mr. Developer, tell me all the vehicles that can float. Easy peasy, right? Write a SQL query, give me the name, vehicle type, and where it runs on, and where the float is equal to yes. So can float is yes into the submarine and into the boat. And boom, you get the boat, submarine, and the boat because it's a duplicate entry. And the developer is super happy, super excited. Yes, my database is working as expected. Hold on that thought. Now, the next query, the user says, okay, find me the vehicle that have tires and it can run on road. In our SQL playlist, we have understood that we can write this query, right? Select star from this table where the vehicle type is this, which has tires, is yes, and it can run on road. Boom, answer is correct. Yes, everything going as expected, right? Users are asking the query, my database is able to provide the response. The third one, find me the vehicle that can fly. The same thing, it has wings and can fly, the returns plane. And the developer is super happy, everything was going okay, perfectly, right? Till the time the developer was super excited. He got himself goggles as well. Okay, now I am the coolest developer which has taken care of this complete requirement. Okay, now let's see what happens. Now, someday what happened? Somebody came and told, show me the vehicle that travel on the road. Oops. Now, if you see our table structure, road is not mentioned as a SQL column. Now what happened? Because if we understand as a human, road refers to the land transport. But how would SQL know that the road is a land transport? Now what happens? The developer is worried because unless you have stored a column which says run on road, it won't be able to match, right? And land won't match to the road. So basically you would need one more table, one more basically column which says that yes, it also means road. So this is an example of synonym or a language variation where instead of air I say something else. Instead of land I say which runs on road. Developer is worried. Now, conceptual concept. Somebody told that find me the public transport vehicle. Now, if I ask you guys as a human, right, from this list which you have into the database, tell me which are the public transport, and you would understand that yes, bus and plane or maybe the submarine for that matter can be a public transport. But is that information available into the database? The answer is no. Now, will the SQL be able to relate to that? No, developer is becoming even worried now. SQL fail unless you have tagged the bus and the plane to the public transport category, which you have not done. So either you go on manipulating and adding these columns into this, or you need to find a better solution. See the developer getting worried now, right? Now, you can also get indirect meanings such as show me something that can carry hundreds of people. As a human, I understand that 100 of people can be accommodated maybe in a bus or in a plane. But in this database structure which I have created, there is nothing because the user is asking me an indirect meaning question. Now what do I do? The developer started crying that how do I accomplish all of that? Because you do not have any number filters. You do not have anything which relates to the passenger capacity. and you do not have any filters, because the traditional RDBMS, if I talk about like SQL, relies on the data which you have put into the structure. Now, I just talked about 3 scenarios. Let me give you more scenarios what could happen wrong when you are dealing with such use cases. People can ask for action or verbs. For example, let me put a pointer, which vehicles can fly? So unless you have stored something which can fly as yes, you won't be able to answer. Give me the vehicles used in war under the sea, right? Under the sea and used in war. So under the sea, yes, it is submarine, right? As a user, I'm able to understand, but my table didn't have that information. Contextual query. You can have something which is a generalized query. Show me the passenger vehicles. You can have an abstract query, something like give me the eco-friendly vehicles. Now you do not have the fuel type there. So how would you find out the eco vehicle? You have multi-concept theory, that show me the vehicle that goes on both land and water. And then you need to add something which is called amphibious vehicle, which is not a column into that. But as a human, based on my understanding, based on my knowledge, my context, I am able to answer all of these questions, but my database won't be able to do that, because my developer have to do a lot of coding into that, and the developer start crying when we have all this scenario. And lastly, let's say somebody says a real world phrasing, give me the vehicles which run on diesel. Boom, SQL fails. Now what do we do? Let's try to understand why SQL alone is not enough. SQL is great. I'm not saying that we should not use SQL, but it is great for structured, exact queries whenever you have data which is and can be accommodated in rows and columns, as we have seen into the previous playlist and the use cases, right? It's awesome there. But it struggle when you have synonyms like road versus land, when you have concepts like public transport, when you have context, when you have human like phrasing. As the human, when we talk to one another, we don't use the exact synonyms, right? We used to just like phrasing languages, right? That's why it is not able to understand. SQL only answer if we ask the exact right words, otherwise it fails to answer me the queries. Now let's meet something smarter and also make our developer happy, who is actually now with his own super goggles is crying now, right? Let's try to make him happy. Now the question is, Mukesh, how can we make the developer happy? Okay, before I go to the solution, I hope you guys understood what is the problem, right? Because that is important to understand the benefit, that first you understand the problem. In case you understood the problem, maybe just comment down understood the problem, or maybe understood or whatever, right? You can just mention that drawbacks of SSMS, whatever you mention, just put it in the comments so that I understand that you guys understand the problem. Then only you would be able to understand the benefit and understand the context. I'll wait for your comments and let's try to make this guy happy now. Okay, cool. So let me try to introduce you to something which is called vector. Tan, tan, tan. What exactly is a vector? A vector is a list of numbers, same like coordinates on a map. Don't go by the definition, I'll explain you. Okay, now these numbers are captured by the meaning, word, or a image. In the database, you store everything into the rows and columns. In the vector, the information is put on a map. Computers can compare these numbers with one another. What exactly I mean by that? This is a vector. Into my traditional SQL databases, I was storing everything into rows and columns. However, into my vector, everything is stored into something which is a 3-dimensional kind of chart. This is just for illustration purposes. Now, the good part about it is, as I was mentioning, it is the number of coordinates, and these numbers capture word, sentence, image, and the information which is closed are stored closed. What exactly that mean? So today, if I have to store our vehicle information into this chart, how would I plot that? Car, yes, it's a vehicle, so it's a car. Bus is also a vehicle, coming closer to the car because both of them run on land transport. Ship is also a vehicle, but it runs on water, have the same properties but a characteristic is different. Show is stored a little bit down. Cat is another object, is an animal stored into a different vector or to a different dimension. Dog is an animal close to that but far from ship, bus and car. Fish again is a animal, right, into the animal category but closer to the ship because both of them have a common property which is water. So if I store the information something like this is called storing the information into coordinates, right? Now, how would the vector database work if I would have stored the information in like this? Let's try to see that. Vector database retrieve the data using something which is called vector search. Okay, vector search relies on the embedding. So all of these black dots would have a number which I'm going to show you what exactly is that embedding, and it will identify that which two numbers are close to one another. The good part, the data here can be text, images, songs or even videos can be stored into this format. Vector database use vector indexing to quickly find the object as scale when the volume grows. Lastly, vector database use vector indexing. It is able to index the embeddings of the vector and able to find the element. In simple words, similar meaning means closer vectors. So similar meaning like bus and car, both of them are vehicle, works on run on land, are closer. Ship is also a vehicle, closer to this but is also closer to fish because both of them are swimming into, fish is swimming and the ship is also sailing on water, so water becomes a common attribute, right? Now what exactly is that embedding, what exactly is that dot which stores that information? So in today's world or the modern use cases, most of the data is unstructured, which means that the data is not always stored in rows and columns. The data can be documents, social media posts, email, audio files, video files and all kind of unstructured data. Now traditional databases used to struggle when they have to store this data. For example, if I ask you that this is one social media post, this is the other social media post, tell me are these posts similar or not? If I try to store that information in SQL, they won't be able to do that, right? Now that is where we have something which is called AI models. So AI models convert all these unstructured data to a long list of numbers which is called vector embeddings. Each number have something which is hidden feature about that. So for a car it would be a different number, for the bus it would be a different number, but both the numbers would have some kind of similarity. In simple word, similar meaning means close vectors. As an example, right? When I am storing the car into my vector database and the embeddings I am creating generated by AI, the car would have parameters something like this: 0.87, 0.78, 0.82. The bus will have this and the boat will have this. Now if you relate to this closely, bus and car are close, 87, 79, 83, because both of them are land vehicles. Boat, however, is a far away because it is a water vehicle. So yes, the information is stored, but since both of them have the same properties, the vectors are closed, and these numerical numbers are called embeddings, and embeddings are created by AI models to store the information into the vector database. Okay. Now from our use case, whatever we just discussed, right? If I would have to put that into a vector database, what exactly it will look like, right? So for example, this is the vector. So for land, I say 0.90, for sky it is 80, passenger is 85, this and this. So all of this combined will give you this number. So if I have to store, let's say, the information of a car, the vector would be 0.87, 0.85, 80, 20, 1 and 0. How would this number be created into the vector? So does it work on land? 0.87? Yes, it runs on land, right? Car. Can it work on sky? No. So the vector is 0.005. However, if you see the second thing for the plane, 0.92, because yes, it can run on sky. Car, can it carry a passenger? Yes, it can carry a passenger. What is the fuel? 0.20. Wheels? Yes. Wings? No. 1 and 0? No. Right? For the plane? Yes. Wheels are 1, wings are 1. For the boat? Wheels are 0, wings are 0, but the passenger is 0.60 because it can also carry passengers. For the submarine, land no, sky very less, wheels no, wings no. And this is how the vectors are plotted. Now when you actually ask any question to this, the question would be converted and it will be related to the relevant vector, and then it will give you the answer. So here in this plot, I have tried to make you understand how does the embedding will actually work, right? So for example, wheels, you can either have wheels or you don't have wheels. That's why you would see 1 and 0, right? Wings, either you will have wings or you don't have wings, right? So 1 and 0. So if you see this now, this is how the vector embedding will look like. So unlike my traditional databases where I store the data into rows and columns, I would be storing these numbers, which is called embeddings, and these embeddings are created by a artificial intelligence model, which is called also known as the AI model, right? And this is just for an example, but the real one can be very long, very big, right? But since we are trying to understand the concept, this is how the data would be stored, right? And now if you just take some time and try to understand this, you will be able to relate to that. If I have to find a similarity between bus and a car, you would see that both of them are mostly similar. However, boat and submarine, 0, 0, 70, 60, 10, 25, 0, 0. Boat and submarine are similar, right? Plane and boat, entirely different, right? Because of the thing. But because of the passenger capacity, if anybody asks a question related passenger, then you might get both of these. So all the question which the developer was struggling can be now answered by using the embeddings, right? So that is how the embedding works, and I hope you guys understood the concept. If you guys are able to relate to what exactly is embedding and the benefit, just comment down vector embedding so I understand that you guys followed the video. Okay. Now, once you have the embedding, this is how all the questions can be answered, right? The car is a strong land, no sky. So this is how the AI will be able to relate to that, and any question you ask would be answered from this matrix using these parameters, just for an illustration purpose. Okay. Now, let's try to go to the definition. What exactly are the vector embeddings and how that will relate onto the map, right? So vehicles that are land or sky, y-axis, z-axis, this is how it would be plotted into the 3D space. So all those numbers which you see in this, if I have to plot those number into the previous one, I had that black dot, but now we understand the embeddings. If I put this embedding, so this would be the numbers: land infinity, sky infinity, passenger capacity. And based on those number, this is how the plotting will look like, right? X, Y and Z axis, land, sky and the passenger capacity, and based on those numbers you would be able to plot that information into that vector graph. So if you try to look into the vector space, that's how it will look like. And when you ask a question about anything, you would be able to get the answer depending on the similarities, right? So this is the example that how it will look like. And these are the same numbers which the AI will generate for us, known as the vector embeddings. Okay. Cool. So now, till this point, we understand what is vector database, how it is different, why it is important. Now the question arises, why vector database are actually required in the real world? Most of the data is unstructured, as we already mentioned: emails, PDFs, chats, images, post. Traditional SQL can't search the data through effectively because the data is stored into rows and columns. Vector database enables the semantic search, recommendation, AI reasoning over such data, right? Which we have seen into this part. They bridge the gap between the human language and the machine understanding. As a human, we don't talk in exact phrases, right? We talk in human language, we query in human language, and vector database fill up that gap. What could be some of the examples in the enterprise? Search for supplier delay policy, get me the right document, even the title is vendor SLA agreement. So if you have such kind of use cases where the information is in a SLA document and you are not specifying vendor SLA document, if you just specify that I want to know that what is my supplier delay policy, it will understand that you are referring to the vendor SLA agreement and not to this. Find similar invoices or compliance report with just structure name. I can just say give me all the bills which I have raised to the company tutorials by Mukesh Kala, and it will be able to get me all those information, right? If you are someone who is coming from an RPA background, you understand that understanding the context is difficult for the robots, and vector database is a core part of your agentic automation. And because of the vector databases, it is possible for you to understand the context while you are processing any information or any of the documents, right? So that is pretty much I wanted to cover on the vector database concept, right? I hope you guys were able to follow along the basics of vector database. And now if somebody asks you what exactly is a vector database, why do I need it, you have the answer, right? If that is the case, just let me know into the comments, right? If you have any more question, any more comments, feel free to write me in the comments, or you can also drop me an email as well. With that, wrapping this video here. Thank you so much for watching. If you like the content, make sure you subscribe to the channel, and see you in the next one. Bye.